Καλησπέρα και καλώς ήρθατε στην Βρετανική Σχολή. Λέγομαι John Bennett, είμαι ο διευθυντής της σχολής. Good evening, everyone, and welcome to the British School. My name is John Bennett, I'm the director of the school, but it's my pleasure this evening not to continue, but to hand over to Vangelio Kyriadzi, the director of the Fitch laboratory, who will introduce this evening's speaker.
Αγαπητοί συνάδελφοι και φίλοι, κυρίες και κύριοι, θα ήθελα να σας καλωσορίσω και εγώ με τη σειρά μου σε αυτή την εκδήλωση του εργαστηρίου Fitch. Dear colleagues and friends, ladies and gentlemen, my turn now to welcome you tonight to the Marc and Ismene Fitch Laboratory annual lecture. Our aim tonight is twofold: to celebrate the 30th anniversary of a publication that had a leading role in the development of the field of ceramic analysis in the Aegean, but also to honor the person behind this book, Richard Jones, who has recently retired from the University of Glasgow. With a degree in chemistry and a PhD in biochemistry, Richard came to Athens in 1974 to work at the Fitch laboratory. It was 29th November 1974 that the Marc and Ismene Fitch laboratory was inaugurated, and Richard Jones was appointed its first research officer, later to become its first director. The Fitch was one of the first archaeological science laboratories worldwide, but possibly the only one that was part of a humanities institution originally housed in a storeroom built after the Second World War by the Red Cross in the corner of the BSA's garden. Its operation was, at least initially, a one-man show. It was an experiment that proved to be quite successful, both for Richard and for the BSA, since Richard stayed at the Fitch for almost 20 years, and the Fitch was expanded and established as a center of scientific research with focus on ceramic analysis. Richard created a wide network of collaborations in Greece with both archaeologists and scientists from the Archaeological Service, other foreign schools, and Greek institutions like the IGME and the Demokritos Laboratory. He undertook a large number of projects, mainly on pottery, from Neolithic to Byzantine, in Greece, Cyprus, and Italy, but also initiated research on other materials such as pigments, metals, and stone, not to mention his work on geophysical prospection of archaeological sites. Through his collaborations, a number of resulting publications and a series of meetings he regularly organized at the Fitch contributed crucially to the introduction and establishment of archaeological science in Greece and in Greek archaeology. The Greek and Cypriot Pottery, a review of scientific studies, published in 1986 as the first Fitch laboratory occasional paper, comprises the highlight of his contribution, a seminal volume still a valuable source of information 30 years later. Richard collaborated very closely with Hector Catling, the then BSA director and founding father of the Fitch, but also with Marc Fitch. And it was due to the hard work, the vision, and the will of these three people that the new Fitch was constructed in 1987, becoming an archaeological science center both for material and environmental analysis. In 1992, after his successful term at the Fitch, Richard Jones was appointed lecturer at the archaeology department of the University of Glasgow. He escaped Greek pottery for a while and immersed himself in things Scottish. He developed a long connection with Orkney, the Cyclades of the Northern Isles, focusing on the study of Neolithic unstand and grooved ware. He also began a project on steatite, used in the Viking world as a substitute for clay. That was a happy collaboration, as he mentioned to me, with Yannis Basiakos and Vasilis Kilikoglou, as they also looked at Cretan steatite. Richard also developed an interest in non-destructive analysis and ran a Leverhulme Trust-funded project looking at the role of portable instruments both in archaeological and conservation science. while he continued research with the use of geophysical techniques, now in Scotland, exploring Roman military installations. He has never, though, abandoned Greek pottery. The two recently published volumes he co-authors on the transport stirrup jars of the Bronze Age Aegean and East Mediterranean with Hal Haskell, Peter Day and John Killen, and on the Italo-Mycenaean pottery, co-authored with Sara Levy, Lucia Vagnetti and Marco Bettelli, comprise significant contributions to the study of Bronze Age Mediterranean and give testimony to his continuing engagement. Richard has never abandoned the Fitch too, as he has served for many years as member of the Fitch Laboratory Subcommittee. For all these reasons, we are very happy to have him with us tonight, back to Athens and to the BSA, his home, celebrating the 30 years of his influential publication. Who would be more appropriate to talk about Greek and Cypriot pottery, a review of scientific analysis 30 years on? Richard Jones.
Well, thank you very much for that very generous introduction. I'm very happy to be here today to give this talk. It's great to be back in the school, back in the Fitch laboratory. Lots of nostalgia, but I hope that's not going to spill over to what I'm going to talk about today. So I thank the British School, John Bennett, and particularly Vangelio for sort of arranging this event today. So this book that Vangelio has kindly introduced for me was a very hefty piece of work, an impressive list of topics that were covered in this large book, this doorstopper, as my wife likes to call it, dealing with Cypriot pottery as well as Greek. And if we look at this list, it is a reminder, if we in fact need a reminder, of the still dominant role that pottery plays and will continue to play in Greek archaeology. Well, why write a review of this kind? It's because I recognize that a lot of science-based work on pottery had been going on in the 1970s and early 1980s. Some of its results rather ill-digested, and some of those results not making very much impact in the archaeological community. In other words, mainstream archaeologists working in Greece were aware of science-based techniques and some of the results that analysis could give, but they were not participating in that process in a great way. And I felt that if the field of applying scientific techniques to Greek pottery, Cypriot pottery, were going to progress, it needed some kind of review and synthesis. So what I got to try and give today is just a taste of how things were, what we knew at the time that I was writing this review, 1970s, early 1980s, and then give a sense of what has changed and what we may be looking forward to in the future. Now, I recognize straight away this is an enormous task, a very large task, and you may well find that some of the treatment I'm giving is cursory, summary, and so I do invite your pointed, detailed questions after I finish talking. Yes, well, we've already seen those pictures. Based at the Fitch laboratory, a smaller, quieter laboratory than it is today, I was, in fact, in a remarkable situation, a very fortunate situation, to be able to undertake a review of this kind. With the use of the brilliant library of the British School, and it had to be the library. Of course, in those days, no online access to literature of all kinds. So I buried myself in the library, looking at the archaeological and the archaeometric literature in books, in journals, in monographs, you name it. And there were chapters in books devoted to the science-based work on pottery. There were journal articles. Some of those books had appendices, and that's where the scientific data was often relegated. And more than that, there were often nuggets of priceless information that appeared in footnotes scattered across the appendix or the main text. So I had to cast my net wide. It was an amazingly dispersed literature. But on the positive side, the people active in the field at this time were relatively few in number, and I knew most of them personally. Now, a very important point that I realized very early on was that it was no good me presenting this hard, sometimes rather dry, often definitely dry scientific data. There had to be some kind of balance, and I was very lucky to be able to call on those people on the screen there who were able to write a commentary, some comment on the work, the science-based work that I was dealing with, put the results into archaeological context, to apply a critical eye. Sadly, only two people on that list are still with us, John Boardman and Marc Pollard at the Research Lab for Archaeology in Oxford, and he contributed the section on data analysis particularly of chemical data, cluster analysis, principal components analysis, that were just coming into the mainstream in the 1980s. And they all contributed in their own way. John Boardman was very precise and brief, succinct in his comments on work dealing with the historical period pottery, whereas Hector Catling, one of the founding fathers of this kind of work, provenance determinations by, say, chemical analysis, was much more discursive and very critical in places of people's work and methodology and interpretation. So the Fitch laboratory was probably the most active laboratory at this time, late 1970s, early 1980s, in terms of using chemical analysis to expand the pottery map, shall we say, of Greece, and to use that reference data to resolve questions to do with origin or status of classes of pottery. And those classes of pottery were nearly all Mycenaean and Minoan. This work was a very definite continuation of a tradition that had been established at the Oxford laboratory, where the correlations between chemical composition and provenance or origin were first investigated in the 1960s. But there were other laboratories also active at this time. The lab at Democritus was using neutron activation. There was a lab at Oxford using optical emission spectroscopy, now a discarded, very old technique. And then neutron activation was being used at the Lawrence Berkeley lab in California and at the Brookhaven National Lab in New York State. And they were all tackling similar questions using neutron activation to resolve questions to do with mainly the origin of prehistoric pottery, but not exclusively so. Now, in introducing the kind of work that was going on at this time, I'd like to move sideways, but stay with the lab at Democritus and to show you this picture here, where very important work was done at this time, late 1970s, early 1980s, by Yannis Maniatis, who I'm delighted is here today, who was interested not in provenance, but in technological questions of pottery and the issue of how we determine the firing conditions, and in particular firing temperatures ranges of ancient pottery. And he used his own work to show that by looking at the microstructure of pottery with the help of the scanning electron microscope, the microstructure of the pottery varied as a function of firing temperature, firing conditions, and the type of clay. So we have in this image a view under the scanning electron microscope of pottery fired to quite high, and it's showing indications of the vitrification of glassy areas in the microstructure, indicating in this calcareous fabric quite a high firing temperature, and then comparing it with that, where the firing temperature has gone that much higher and the amount of vitrification has increased enormously, hence a much higher firing temperature. But here was a really objective means of getting this basic technological information. I want to stay with technology and make the point now that not everyone working in this sort of field, science-based work on Greek and Cypriot pottery, was a full-time archaeological scientist. There were a lot of people, and particularly the early workers dealing with black gloss, unfortunately still called black glaze by many people, trying to understand the material that was used to make the black gloss. It was established a long time ago that it was a clay, a very fine textured elytic clay, that on firing under the right conditions would sinter and in that state would be impervious to how the firing conditions in the kiln were altered. The point I want to make is that going on from that early work, there was a group of industrial chemists, not archaeological scientists, Walter Noll and collaborators at Leverkusen in Germany, who used the same technique, the scanning electron microscope, with an analyzer attached, to look at the decoration, the decorative techniques on prehistoric pottery. So he and his team looked at Kamara's ware, Mycenaean pottery, all the way through to say, this class of pottery, white ground lechithoi, where the pigments were applied after firing. So the reds and the blacks, the yellows and the greens, they were identified using his techniques. Very early work, but very effective work. I'm staying on this theme of people who were not full-time archaeological scientists working on Greek pottery. They had other specialisms, and here I look at this very contrasting example taken from Ephesus. This concerns archaeomagnetic dating, and pottery holds a record, shall we say, of the magnetic configuration, magnetic intensity in this case, that was frozen into the pottery at the time that the pot or the ceramic was fired. Now, Anton Bama applied this general approach to structures at Ephesus with very, very effective results. Here we have on this graph here the magnetic intensity value, and along here, date. And it is very, very fortunate that at the time, early historical period from about 200 AD to about 1450 or 1500 BC, the way magnetic intensity changed in a secular manner changed very dramatically over time, up and down, then there's a gap, and then it comes down. And what he was able to do was to construct this reference curve using material from very well-dated structures at Ephesus, from Gelser's library, 125 AD, right up to this mosque here, and then to consider brick and tile diagnostically very, very poor in terms of date, and yet so common at large historical period sites like Ephesus, determine their magnetic signature in terms of intensity, and thereby date the brick and the tile using his reference curve, and thereby help date problematic sites that the Austrian excavators at Ephesus were trying to date. We move on to early work. As a contrast now, organic residues. What was the function of pottery? What was pottery carrying? And again, this was a very unspecialized field, and organic chemists were drawn in now and again to have a bit of fun to see what was in the pottery. Here is a nice example where it did work from Vari House in Attica, and the calathoi and the resinous looking material inside was duly analyzed, and we've got here the response of gas chromatography that is showing the individual components, the fatty acids associated with the residue in the calathos. And can you see a very good match between standard beeswax, which is the chromatogram A, and the material extracted from the calathos, which is B. A positive identification of most likely beeswax, and so the idea that these pots were in effect beehives. In these early days, then, a progress towards identifying the chemical markers for wine, for foodstuffs, but it was still very difficult work. I'll come back to that later. The most attractive feature or topic that I had to write in this book was the evidence that traditional potters in Greece and Cyprus were able to give. Here was superb information helping us on where potters were gathering their clay, the procedures they used to purify the clay, how they were making their pots. Using the evidence of traditional potters, we were still very lucky that many of these potters were still operating then, even though the traditional craft was in serious decline by the 1980s. Some images there from Greece, and equally valuable information, this slide from Vangelio, equally interesting information that we get from these traditional potters on distribution, export of their products. So Thrapsanos potters in central Crete somewhere, cooking pots and other pots being dispatched from Sifnos, and over on the right, the pale water jars of Aegina, ready for dispatch for export. Well, now I'm going to very briefly run through the kinds of results that are emerging from this early phase. And let's just begin with the Neolithic and early Bronze Age. So a very limited amount of work had been done at this time, by the early 1980s, concerning Neolithic pottery from those sites, and a nice example taken from Katie Vitelli's book on Frankfurt Cave Neolithic pottery. And here, petrographic analysis was able, quite effectively, to demonstrate that the macroscopically different kind of fabrics were meaning a lot petrographically. In other words, that the potters, we presume women, were gathering a wide variety of clays and sometimes adding, or naturally present, an exotic range of inclusions. In other words, the recipe that individual potters or groups of potters within, say, a household was something very personal, and that was being demonstrated in terms of the clays they collected. By complete contrast, by the early Bronze Age, look here, thank you, at pottery exchange in the Corinthian Argolid, very ambitious early work using neutron activation on this kind of pottery, the early Helladic II source boat of the Corinthia and Argolid. And what Michael Attas was trying to do was to look at the movement of this kind of pottery within the Corinthia, from Lake Vouliagmeni, Corinth, sites in this sort of area here, down to Argos, Lerna, Tiryns, and so on. And indeed, he was finding positive evidence for the circulation of this class of pottery. I'm shooting straight on to late Bronze Age 1 and 2. A lot of work was done in these early years. And the kinds of questions were all on decorated pottery, and all the work was chemical analysis, nice example here. And the kinds of questions that were being asked were, well, let's take marine style from different find spots. The question being asked of chemical analysis, was the marine style so well defined stylistically coming from the same place, or was it being made in different places? We showed that it was being produced in different centres. Other work based on Knossos, Philakopi and Aierini were such good pottery, definable pottery of this early part of the late Bronze Age was to be found. And then early work on Minoanizing pottery in the South Peloponnese. When we come to late Bronze Age 3, a vast amount of work was done that I summarize here, and I'm not going to go through it in any detail at all, just to show that at this early time, these questions regarding identity of pottery, is this Mycenaean pottery a typical example of, say, the northeast Peloponnese, or is it being made elsewhere? Use the chronological factor. The sources of pottery in the later periods are very different from the patterns of distribution at the start of LB3. The results were reasonably good, but they were very varied, and the success of the work was very much a function of how good, how powerful the analytical technique, chemical analysis, was. So techniques like neutron activation had a very considerable advantage over techniques like atomic absorption or optical emission. You see, I'm moving rapidly now, and we're moving to Cyprus, because I keep on emphasizing that Cyprus was very much part of my brief. And petrographic analysis appearing in early prehistoric pottery, red polished ware, white painted ware, red polished of early Cypriot period, using petrographic analysis to get the first indication of regionalism. The pottery was being made at this early period in different parts of the island. Contrasting with early, late Bronze Age period, the well-known white slipware, where it was beginning to be appreciated that here was a fabric that was centered in one locality, the foothills of the Troodos Mountains, because the fabric was very special, and the white slip was an associated material, also very special, from very few locations. So good progress there. And at the other end of the spectrum, provenance determinations on supposedly imported pottery, prehistoric pottery found on Cyprus. Tel Yehudie example there, imported from from Egypt. And then many, many questions on the status of significance of wheel-made Palestinian bichrome ware. Cyprus was supposed to be an island where the fast wheel was introduced very late on. The results of analyses indicated that, in fact, examples of this Palestinian bichrome ware were being made in Cyprus at this early time, as well as, of course, as in Palestine itself. This well-known class of pottery that needs no introduction, but my goodness, in the 1960s and the 1970s, up to the time that I was writing about it, so much indecision and debate about what this pottery represented and where it came from an archaeological perspective. Was it made where it was found? Were there emigrant Mycenaean potters who were making these pictorial style vases for the markets in Cyprus or elsewhere? Well, chemical analysis was very decisive on this point. This was a product of the northeast Peloponnese. Now we know more precisely where in the northeast Peloponnese it was a special export item. And we also know, again through chemical analysis, that a later derivative of pictorial style in Cyprus, pastoral style, was very much a product of Cypriot workshops. When we come to the historical period, the floodgates open again. An enormous amount of work was done. Lots of programs of analysis were carried out, again for information on provenance. Associating classes of pottery. Did they stylistically define classes of pottery? Could they be associated, linked to a single source or to many sources? Making negative statements about origin if we could not make a positive assignment of origin. The largest program of analysis was that initiated by John Boardman, and it was, by all accounts, very audacious and ambitious. We start off, we have to use this map because it was taking Greek pottery found throughout the Mediterranean. So questions of identity on Greek pottery up there from the earliest Greek colonies in the Bay of Naples at Pithecusae, at Cumae and elsewhere. Questions of identity regarding Thapsos, where was it all made in the Corinthia or was some made in Sicily? The pendant semicircle scyphoi up there, so well defined. Examples found in Almina, in Cyprus and elsewhere. Always products of Euboea or not? Several questions that could be tackled by chemical analysis again. An example here of the remarkable skill and audacity of being able to get samples of, well, here's the Cesnola crater. It was duly sampled in whichever New York museum it is. And at that time, in the 1970s, the debate was whether it was a Naxian product or whether it was from Euboea. Chemical analysis tended to show that it was more likely to be from Evia. And we move eastwards. Ficalura pottery that was thought stylistically to be linked to the island of Rhodes was shown by analysis, work done in Oxford and by Pierre Dupont in Lyon, to be much more likely a product of Miletus and that part of Ionia. Example of the running man Ficalura pot. And then examples of wild goat style, indications from chemical analysis that it was a product of many workshops in northern Ionia. Bit of light, not necessarily light relief, but I want deliberately to show you this picture, which you'll recognize as an aerial view of Thorikos. And almost everything I've said so far has been decorated, fine, Greek pottery. But what about humble cooking pots? And I was able to include in Greek and Cypriot pottery, in the review, one of the first examples of taking coursewares seriously. And a study by Paul de Pape looked at examples of cookingwares. These, of course, are examples from the Athenian Agora, but he used examples from the excavations at Thorikos to show by petrographic analysis, nice coarse fabric, that many of the coursewares found at Thorikos had no connection with the metamorphic geology of Attica, but instead could be linked to the contrasting geological environment of Aegina. So from that point on, there's more than a suspicion that Aegina was an important producer in the classical period of cooking pots. And as we'll see a bit later, we understand better the reasons why Aegina had that increasing monopoly on the production of cooking pots. So I've shot through what we sort of knew in those early years, and now we've got to consider where we are now. And I move straight to Corinth. And it was work by my colleague, Ian Whitbread, based at ancient Corinth, with a very full cooperation of the American excavations there, and in particular Charles Williams and Nancy Boukidis, who I'm so pleased are here today. And Ian began work in the 1970s on the petrographic analysis of many classes of Corinthian pottery, in particular the transport amphorae. So here we have the transport amphora type A and a view of how it looks in thin section, the mudstone inclusions, and then type B, Corinthian type, with a very different composition, and now shown not to be Corinthian, but most likely from Corfu, but we'll leave that aside. And Ian was really developing the petrographic approach and doing a lot of clay prospection, realizing that, for example, the terra rossa clays were being used for the production of the type A amphorae, and the mudstone, Hornfels type rock being found between the Terra Rossa clays and the beginning of Acrocorinth. So he really developed that very fully and was then able to extrapolate that to look at production, the characterization rather, of all the main transport amphorae of the classical and Hellenistic periods, from Rhodes to Thassos in the northern Aegean. And that led to this fundamental work that he produced, which included all his work at Corinth, all his work on the transport amphorae, the different classes of transport amphorae, and, crucially, the full details of the methodology of fully describing, very rigorously describing, what one sees in thin section of pottery. And it's that methodology that continues to be used today. He really set a standard. So the Fitch was leading the way in, or prominent, shall we say, in the use of petrographic analysis. This approach was being used very effectively elsewhere. On Crete, INSTAP set up at its centre in East Crete a lab for petrography. Sheffield University Archaeology Department, the work of Peter Day and collaborators, also very much involved in that kind of approach and continuing to be very important. If we look at chemical analysis, Hans Mommsen done so much work with nuclear activation, based at Bonn, but working in a country, Germany, which no longer had nuclear facilities, and so Hans Mommsen has been peripatetic, going around Europe, finding nuclear reactors where he can continue to do irradiations and can continue to do his good work. Nuclear activation at Manchester University in the 1980s and 1990s. And then a change as nuclear reactors became less and less prominent or available, the use of a new generation of XRF, wavelength dispersive XRF, at the Fitch, the lab in Lyon and in Berlin, both those two labs being involved in work on Greek pottery. The archaeometry lab at Democritus was diversifying, as I'll say later. Organic residue analysis, that I abbreviate to ORA, being carried out very recently at that university, Heracopio University in Athens. Laser-induced breakdown spectroscopy and Raman spectroscopy at this institute in Heraklion. Those two techniques being used, for example, to characterize pigments on pottery. So what we're seeing is a big increase in the number of labs, a big increase in the number of practitioners involved in work of different kinds on Greek pottery. And I nearly forgot, Thetis, together with the conservation department of the Benaki Museum, doing a lot of work, as we'll see in a moment, on technology of classical period pottery. But if we go back to, shall we say, classical, traditional provenance work in this new wave, that is work done since the 1980s, what do we find? Well, I have to start off with this, and I'm showing it to you because this unique, fortunate situation, whereby we have, in the case of the stirrup jars, late Bronze Age, so well known, so well defined archaeologically, we have that combination of style, type of pottery, shape of pottery. We have the Linear B inscriptions. We have extras like the stoppers and the plugs in a few examples. A long running tale on where these pots were made, which I'm not going to go through, but you may want to bring it up in question. But here was finally an example of a big sampling strategy, well-defined questions being asked of the data that was petrographically defined, and here was petrographic analysis really coming into its own, defining lots of fabrics associated with West Crete, lots of fabrics associated with, I'm going to go back to the map, lot of production of these jars in the Hania area, a lot of production in the western Meseret. This was one of the big surprises, as well as some production in the Knossos area. But the point is methodological that I really want to make. It is the success of the petrographic approach, so visual, so effective, that it was leading, and the chemical work was sort of following, providing good complementary data. One group, another group, another group, and another group. The islands, Greek islands, have always been a very promising, fruitful area for science-based work on the pottery. Crete, as we've just seen, and the INSTAP Centre, Peter Day, Vangelio, and others have done a lot of work on Minoan pottery that unfortunately I can't go through for time reasons. In the Cyclades, exactly the same point to make. Geological diversity, especially in the Cyclades, first explored by Jill Pittenger in terms of characterizing the products of different islands petrographically. Later work by Sarah Vaughan, and most recent work by Jill Hilditch, which is still ongoing. Then we come to Egina, and the recent work by Vangelio and Walter Gauss on pottery from an island, but a single site, Colonna, so productive in terms of pottery, and here was a really successful piece of work, really bringing it all together. The petrographic work, chemical, a lot of clay prospection, defining very accurately and well in terms of the characteristics of this pottery, how it was, where it was exported to, and so on. I think you will have heard, many of you will have heard from Vangelio, if not Walter Gauss, about this, so I'm not going to say anything more about it. But I will just highlight Kythera as another island, and the work of Vangelio and others in the Fitch laboratory on work arising from the Kythera Island project. And here, some really striking results, petrographically based, also requiring chemical analysis, the isolation, the identification of two very distinct clay recipes on the island, sand or mud-tempered, or mudstone-tempered pottery on the one hand, red, much more micaceous type of clay on the other. Very, very well defined. And what was really important was the way both fabrics were finding their way distributed across the island, the sand-tempered pottery being prominent in the east of the island around the sort of focal point of the survey at Castries there. And we're concentrating mostly on the prehistoric pottery, and both fabrics are being found outside Kythera in the southern Peloponnese, even as far as Egina. An additional attraction of this kind of approach was that it could be multi-period, and this kind of fabric identification be extended to much later periods. Back to chemical analysis, and nutrient still enjoying great success on its own. And a cooperation between Penelope Mountjoy and Hans Mommsen, rolling eastwards through the Aegean, looking at regional Mycenaean, through the Aegean to the Dodecanese, their work on roads, and then to Cyprus, and looking at production of LH3C, decorated pottery on Cyprus, as we see here, and really good results in the sense that ability to define what is being made on Cyprus at Hala Sultan Teke, at Kition, but seeing examples of that decorated pottery being exported to places in the Levant. Here is high precision provenance work. And in that vein, I go to this map to make a point that has been arising, has been concerning those of us dealing with chemical analysis, particularly Mycenaean pottery, and the way we've been able to, we need to be able to define where, for example, in the Peloponnese, imported Mycenaean pottery is coming from. In other words, how well can we discriminate between Mycenaean production in the Argolid, in Achaea, right through to Elis and into Western Greece. And the problem has been that it has been very difficult indeed to discriminate between products made at Berbati, at Korakou, at Egira, from those produced in Western Peloponnese and Western Greece. Well, I want to say that the combined new work by Mommsen and others on new cultivation is indeed showing small differences, allowing us to discriminate between different regions within the North Peloponnese, a very important point of progress. My work with Sarah Levy, Lucia Vagnetti and Marco Bertelli, Mycenaean pottery of this kind in the West that Vangelio mentioned in the introduction, where we found by a variety of techniques that so much of this kind of pottery was not imported from the Mycenaean mainland, but was being made by emigrant Mycenaean potters and others in Italy itself, that we had to change the title of our work to Italo-Mycenaean pottery. And we enjoyed the way that we were able to combine chemical analysis with radiographic study, x-raying of pottery, to look at how this pottery was being made, how it was being constructed, as well as technological data on the paints and some replication work as very attractive added extra. So a lot of new work on the provenance front, and generally good progress as a result of increasing the number of samples to be analysed, using as powerful techniques as possible, exploiting the databases, data banks as fully as possible, as well as having a very clear archaeological strategy. I move then to technology and very recent work on black figureware, and to make the point that as a result of Elenia Lupi's work and others, it is now understood that the clay that was used for black figure pottery for making the vase was not the same as the clay material that was used for making the paint. And that was a very important step forward in that understanding. So Eleni Alupi and others have been looking at the kinds of clays that could have been used for preparing the clay suited for paint material. And finding, in fact, that within Attica and in southern Boeotia, a lot of clays have the right properties to be suited to be used as a clay material and giving very high quality gloss decoration. With a very overt move towards mechanical properties, it is very appropriate that the Democritus Laboratory in an Institute of Material Science should be focusing on thermal and mechanical properties of pottery. Kind of work that has really been left aside, but has been enjoying a lot of popularity. Try to understand what was necessary in terms of what kinds of properties we should be looking at in understanding what is required for building a storage jar and what is required for making a good and successful cooking pot. And it is that interplay between the shape, type and frequency of temper, firing temperature and technological tradition, and trying to pick out what clearly was understood empirically by potters making storage jars and cooking pots, but not at the same time trying to push too much technological determinism onto the potters at that time. So I refer to a very recent book that has come out, Ceramics, Cuisine and Culture, where a lot of this work done at Democritus, particularly by Noemi Müller, Anna Hein, and especially Vasilis Kiliokoglu over several years, looking at properties associated with shape, where the pressure points are. They're dealing with a round-based cooking pot or one with straight sides. And at the top here, looking at the effects of different kinds of temper on the shock resistance in cooking wares. So a wholly new perspective on these classes of pottery. Back to organic residue analysis. And I was saying very early on when I wrote the book, it was a field that was very hit and miss, some good results, a lot of very hazy results. Well, then in the mid-1990s, that book appeared. And that really shook things up. It resulted from a very glamorous exhibition in the National Museum, and it toured around Greece and went to Italy. And it was the brainchild of Yannis Tsardakis and Holly Martliou. And it concerned classes of Mycenaean and Minoan pottery, and it showed, we'll show it to you in a moment, that some really exotic drinks and foodstuffs were being found as residues in this kind of pottery. Now, almost straight away, the results proved fairly controversial. And so 10 years later, this book appeared, which in effect provided all the detailed background, heavy organic chemistry to the identification of, and here we go. They were coming forward with these nice recipes, indicators from organic residue of beer, resinated wine, wine with another kind of resin, and the whole concept of mixed fermented beverages. Controversial at the time, and still rather controversial because of the difficulty of defining the chemical markers for wine and fermented versions of it, and the resinous versions as well. And look at the foodstuffs, equally controversial, but really making people think about the capability of this approach, if only it could be made really rigorous. So we have those fairly exotic foodstuffs, a fine menu that was possibly available in Mycenaean and Minoan pots. So I think that the whole area of organic residue analysis has really come together. It has become possible to establish much more confident protocols for identifying the residues. And I'd like to take just briefly a very recent piece of work that's been carried out at the Hypogeon of the earliest Greek colony in the north, Methoni, 7th century BC, work done in the Fitch and by Maria Rombu at the Karakopiou University on several amphora types found in the Hypogeon at this site in Methoni. So here was an example of combined petrographic analysis with residue analysis. And it's the residue analysis that I really want to concentrate on. So on the left, a proposed likely lesbian type amphora, and there we see it nicely defined petrographically, and we can associate that petrographic description with the geology of the island. And here on the right, the chromatogram of the residue from one of that particular amphora. And what has it got? It's got those exotic acids, organic acids, that are typical of diterpenoids, and it was therefore interpreted to be a resin. Now, just take a look at some of the other examples of amphorae from this site at Methoni. So we're dealing with early transport amphorae, 7th century BC, and look at the range of residues that are being fairly confidently identified on HEOS, fatty acids. Is it from the plant fatty acids or meat or what? Resin in one of the lesbian amphorae. A mixture of resin and fatty acids in another amphora, lesbian type. Attica, the Attic SOS amphora that we're all led to believe surely transported the best olive oil from Attica abroad. And here it is containing beeswax. Is that just a coating of beeswax on the surface or what? And then we go to the local amphorae. possible plant lipids in one of the amphorae, beeswax in another. Now I'm throwing that at you just to make the point that I think organic residue work really is on a new path, and what it is doing is really challenging those of us interested in what transport amphorae carried to perhaps think again. We've become so used to oil and wine being the standard contents of Greek transport amphorae. I'm running out of time, so I'm going to go very, very briefly through some new kinds of work applied to Greek pottery. And this falls into the category of portable instrumentation that is beginning to make a real impact on what we are able to do on Greek pottery. Radiography, taking X-rays of pottery, using portable instrumentation like that X-ray machine up there, applied by Ina Berg on Minoan pottery, work done in the Stratigraphical Museum at Knossos. I'm going to rush through that. The availability now of portable X-ray fluorescence instruments for carrying out in situ, non-destructive analyses, where, for example, it is not possible to take a sample for destructive analysis from a pot or a sherd. And here's an example of work I've been doing, not in Greece, but in Scotland, on this kind of pottery, terra sigillata, from Roman forts in Scotland, where it's not been possible to take samples, and we've been able to get nice groupings, chemical composition groupings, that do make sense in terms of the known production centres in Gaul, Eastern Gaul, Central Gaul, and Southern Gaul. The approach does work, but this approach is never going to overtake our mainline techniques. Lead isotope analysis. I've not made a mistake here. I'm not giving a talk on bronzes, but here, lead isotope analysis being applied to pottery. Recent work by Renson et al. Applied to Canaanite jars found in a late Bronze Age context at Hala Sultan Teke and Mar Paleocastro. Pottery that is beautifully characterizable petrographically, as we see here. So why use lead isotope analysis? Just look at the results on this graph here, using standard lead isotope analysis on this pottery and finding groupings between the Cypriot products versus examples made in the Levant, possibly Egypt. So we're using lead isotope analysis here because there is good reference data for geological material from the potential source areas, first of all in Cyprus and then in different locations along the Levantine coast and in Egypt. So lead isotope analysis is able to provide an additional dimension of information where perhaps the petrographic is running into some difficulty. There is perhaps a future for that. And finally, back to ceramic ethnography. What's been happening in the intervening time? Well, we know very well that very few of the traditional workshops are still running. And so we've taken a more anthropological, sociological approach to the remaining traditional potters. And Peter Day has exploited that very well in his work on the traditional potters based at Kendri in East Crete and the Thrapsanos potters who set up the temporary establishments in this part of East Crete. And talking to these potters and realizing that at centres like Kendri, a well-known pottery making establishment, issues of marriage and mobility were very prominent in the way this centre operated. In other words, potters from Kendri were not necessarily going to be stationary. Some of them, several of them, did move to different parts of Eastern Crete, if not further afield. In other words, extracting another layer of information from traditional potters that we can use as very valuable background to our studies on earlier pottery. Now, I must, at the end, come to Nectarios Garis, who is arguably the most well-known traditional potter in Greece today. He is wearing, I'm sure you will notice straight away, T-shirt of the Fitch Laboratory Ceramic Petrology course, and here he is wearing it when I visited him this summer. Now, he is tired of me, because I do go and see him every year, asking him questions to do with how he's making his pots and how he's distributing his pots. That is really old hat. So when I met him in the summer this year, I reminded him of the fact, when he was complaining that he never leaves the island, that years ago he told me that he had a big commission to prepare 1,000 pieces of pottery for a convent on Spetses. And I reminded him of this, and he did remember that he had prepared, perhaps it's not 1,000, 500 pieces of pottery being made, commissioned by this convent on Spetses. And he said he had travelled overland and then taken the ferry over to Spetses. And I said to him, well, presumably all this pottery is tableware to be used in the convent. And he looked at me, because he thinks I am fairly crazy for the kinds of things I ask. And he said, no, not at all. This pottery was commissioned and asked for by this convent on Spetses to be used in the chapel or the chapels for acoustic purposes. And so suddenly, all of a sudden, I'd come across a new area of archaeoceramics whereby it is understood that ceramics embedded in the walls of buildings, and in particular chapels and churches, improves the acoustic facilities. And I didn't really believe him when he told me this, but I have since done some internet searching, and indeed, particularly in France, there is quite a literature in this area. Right, I'm going to stop here with some final words. I do want to just look into the future for one very short moment. First thing I want to say in conclusion is that there is no grand unified theory of the kind applied to, say, particle physics that we can project onto the way science-based work on Greek Cypriot pottery is going to go. Greek pottery is so varied, so plentiful, so multidimensional, and now embedded so well into the mainstream of Greek archaeology, that I expect science-based work to continue along the same differing trajectories that I've been talking about today. But there are caveats, and since a lot of what I've been saying to do has got to do with provenance work, determining origin, the success of that kind of work, using the right kind of techniques, powerful techniques of analysis, having good databases, it is always going to reach a limit. And that limit we have to realize, and it is going to affect us more and more. And that limit is defined by geological reality. The geology of Greece is varied, but it's not that varied, and we are going to reach a limit. On the other hand, not to depress ourselves too much, the archaeological record is better, is becoming better, and it is more refined. Archaeological definition of production can now be superbly focused in the light of a well-excavated pottery workshop. And we can use analytical techniques to home in on very, very well-defined material. But nevertheless, I think we've got to match the kinds of questions and expectations we can put on analytical techniques. Always keep that well in mind. Other points that I just throw out now. I think more could be done on humbler ceramics like bricks and tiles, architectural terracottas. I think that some time periods and some regions of Greece have not received the attention they deserve. One of those time periods probably being, or perhaps being, the Roman period. With a greater confidence there is now about organic residue analysis, I think this field has a promising future, especially where it can be integrated into the results of faunal analysis and the results of dietary information arising from stable isotope analysis. I think we should be using our chemical data more fully. It is very easy for labs, and I know this very well ourselves, to carry out a piece of work. We have reference data, it is put into the computer bank, and it never really moves or is used again. The right moves have been made in the direction of using our data more fully, that is, in the form of online databases, and defining better inter-technique and inter-lab comparability. But I think there is more to do in that direction. And finally, all this kind of work transcends increasingly today's national boundaries. This issue is well understood by all those of us dealing, say, with amphory, transport amphory. We cannot just consider Greek territory. We must be used to considering the Black Sea or the Western Mediterranean. So, for example, Southampton University's Roman amphora database, archaeologically very useful, petrographically very useful, is a real step forward. And at a more informal level, the Levantine's ceramic project, taking in as an umbrella all those kinds of work dealing with the Eastern Mediterranean. We need to keep ourselves well informed, and I think that is one of the other ways in which we will progress. Thank you very much for your attention.